Question number 156. There are three oxygen hemoglobin dissociation curves A, B and C. Mark the incorrect statement from following options. And as you can see here in this graph, which represents oxygen hemoglobin dissociation curves, and here we have A, B and C in this order. Now the very first option given is curve B represents oxygen hemoglobin dissociation curve when individual is at rest, and this is a correct option and cannot be a correct answer to our question because we need to find out an incorrect statement, and this statement is correct. Why? Because as you can see in this graph for B, which is this, here you have this % saturation of hemoglobin and this is your P50 value, and we know that under normal physiological conditions in a normal healthy man, hemoglobin gets saturated to about 50% when the partial pressure of oxygen is nearly 30 mmHg. This is under normal physiological conditions. So in graph B, as you can see here, that 50% saturation is occurring at near about 30 mmHg partial pressure of oxygen. So B may represent individual at rest. So this cannot be a correct answer. Our second statement is increase in temperature shifts curve B towards right as represented by curve A, which reflects increase in P50 value. And this is a correct statement and cannot be a correct answer to our question because increase in temperature, that could be at cellular level or at tissue level, the increase in temperature, it will shift the curve from B to A, that is towards right side, and this reflects increase in P50 value. As you can see here, for this, the P50 value will be here. So there is increase in P50 value. So this is a correct statement but cannot be the correct answer to our question. Our next statement is curve C represents a possible increase in pH. By increase in pH we means if B represents normal physiological conditions or individual at rest, thereby increase in pH from this normal level could be alkali conditions, and this indicates increase in affinity of hemoglobin for oxygen, and this is a correct statement but cannot be a correct answer to our question. Why? Because this increase in pH will increase the affinity of hemoglobin for oxygen and will shift the curve towards left side from B to C. Our last statement is increase in P50 value of hemoglobin as observed in curve A indicates enhanced association of O2 with hemoglobin to form oxyhemoglobin, and this is an incorrect option because as we have already discussed that this shift in curve from B to A could be possible by the increase in temperature or decrease in pH, that is acidic conditions, or many other factors which are associated with the decrease in affinity of hemoglobin towards oxygen. So this will lead to dissociation of oxyhemoglobin rather than association of oxygen to hemoglobin and formation of oxyhemoglobin. So this is an incorrect statement and it is a correct answer to our question. So the correct answer for this question is option number 4. Let's discuss our next question. Question number 157. Total percentage of CO2 which is transported through blood plasma is. And we know that maximum percentage of CO2 is transported in plasma in form of bicarbonates. In bicarbonate form, which is nearly about 70%, and nearly 7% of carbon dioxide is transported in dissolved form in plasma. So total percentage of CO2 transported in plasma would be 77%. So the correct answer for this question is option number 3, whereas 7% cannot be a correct answer because it is merely the dissolved form of CO2 in plasma. Option number 2 cannot be a correct answer because 70% of CO2 is transported in bicarbonate forms in plasma. While option number 4 cannot be a correct answer because 23% of CO2 is transported in form of carb amino hemoglobin. So the correct answer for this question is option number 3. Let's move on to the next question. Question number 158. Choose incorrectly matched pair in relation to human excretory system. The very first option given is site for minimal reabsorption in nephron. And the match given is ascending limb of loop of Henle. And this is a correct match. Why? Because this is given in your NCERT book that the minimal reabsorption occurs in loop of Henle. The next option given is conditional sodium reabsorption, and the site given is DCT, and this is a correct match because under the effect of ADH, that is antidiuretic hormone, this conditional reabsorption occurs in DCT as well as in collecting tubules. The next option given is reabsorption of bicarbonates, and the site given is DCT and PCT, and this is also a correct option because reabsorption of bicarbonates occurs in distal convoluted tubules as well as in proximal convoluted tubules. Our last option given is absorption of urea, and the site given is collecting duct, and this is an incorrect option and is a correct answer to our question because it is the secretion of urea and not absorption of urea, which occurs in collecting duct. Collecting duct secretes urea into the interstitium fluid, thereby increasing the osmolarity of this medullary interstitium for the reabsorption of water. So the correct answer for this question is option number 4. Let's discuss our next question. Question number 159. If stretch receptors in wall of urinary bladder are destroyed, the first option given is micturition reflex occurs normally. And this is an incorrect option because this signal for micturition reflex, this is initiated by the stretching of urinary bladder when it gets filled. So this is an incorrect statement because if stretch receptors are non-functional, micturition reflex cannot occur. The next option given is filling of bladder remains unaffected, and this is a correct option. It is a correct answer to our question because filling of urinary bladder is independent on stretch receptors. The next option given is person has to undergo hemodialysis, and this is an incorrect option because hemodialysis is required when there is malfunctioning of kidney. The last option given is formation of urine comes to halt, and this is incorrect because formation of urine is independent on the presence of the stretch receptors in the wall of urinary bladder. So the correct answer for this question is option number 2. Now let's discuss our next question. Question number 160. During ventricular systole in human heart, first option is closure of semilunar valves occurs, and this is incorrect because it is the opening of semilunar valves which occur during ventricular systole. Because during ventricular systole, when the ventricle is undergoing contraction, there is increase in the pressure within these ventricles. And when this pressure exceeds the pressure present in aorta, there is opening of semilunar valves present in the walls of aorta. The next option given is blood enters ventricles from auricles, and this is incorrect because blood enters ventricles from auricles during atrial systole and not during ventricle systole. Now, third option given is pressure within ventricles increases, and this is a correct option and is a correct answer to our question because as we have already discussed, during ventricle systole, when the ventricles are contracting, there is increase in pressure within ventricles. The last option given is opening of cuspid valves takes place, and this is incorrect because during ventricular systole there is closure of cuspid valves. There is closure of tricuspid as well as bicuspid valves, or also known as atrioventricular valves, present between the auricle and ventricle of human heart. So the correct answer for this question is option number 3. Let's discuss our next question.